It is my pleasure to introduce to you our speaker for today, who is Elisha Bere. And the topic that we have for today is from Arduino to AI, the weekend project that grew into a game changer. And during this presentation, Elisha is going to take us through how he managed to work over an innovative project over the weekend, which I believe is something that's very useful to all of us, that we are pressed for time and we sometimes can't even find time to innovate. But luckily, Elisha managed to do it. So he's going to give us some nuggets on how he has done it. And at the end of the presentation, we are going to have an opportunity to ask questions. But if we look at the platform that we are using, if it is your first time, if you check on the right, there's an option for chat, and there's also an option for question and answer. So if you press on the Q&A only, you are able to type in your question, which will be very good because it will help us now to ask Elisha to explain further. So I would encourage you to use it during the presentation, and then at the end of it, we can now go through all those questions. The chat, we can just use it to greet each other, to connect, but the Q&A is the key sort of tab that we really want to look at. Then, yeah, I'll hand over to Elisha to give us a brief introduction of himself. And as soon as he's done, he's going to take us through the presentation. Over to you, Elisha.
Thank you, Kurai. Thank you very much, Kelvin, for inviting me and having me present some of my small ideas that I build on my weekend free times, and being told that, you can share this with the community. It's kind of interesting. It's something that drives me to keep on wanting to learn and also maybe wanting to share what I've learned in this whole journey. So yeah, like Kurai said, my name is Elisha Bere. I'm a software developer full-time and an innovator part-time. I enjoy working with IoT and AI on my part-time, including some electronics, because what's software without hardware, right? So yeah, basically that's briefly more about me, and hopefully after this chat we'll connect, share ideas, and build some cool stuff for Africa. So I'll start the presentation on my side. Okay. All right, so so the topic I put on the slide is kind of different from the topic but it still correlates. I just felt that this was more kind of like creative, but the point of it all is how a weekend project grew into an AI farm assistant that can also work for your home security. So from curiosity to creation, basically. So yeah, today I want to take you on a journey, and from a young kid who was always curious about how things work, and also being signed up to engineering school to become a mechanical draftsman, which is kind of weird because now I'm in software, and to becoming a software developer, and eventually finding myself playing around with electronics. I've always found myself being someone who's very curious, and my curiosity is what has landed me into these various fields of engineering. But I believe, I always say this when I'm talking with my friends, they say it's the cycle of life, because I found myself going back to where I started, but it's all driven by these software solutions that I have in mind. But then I find that, I still need the hardware to it. And then it takes me back to the drawing board, and I find myself still doing computer-aided drawing, which is the main job which is done by mechanical draftsmen on a daily basis. So as I was being curious, playing around with things. I found myself building solutions that blend agriculture, AI, a bit of healthcare. So I've done some topics on applications of AI in the healthcare sector. But with this one, it was kind of different, where I thought about integrating agriculture and home security into this one compact board. And this is a story just about curiosity learning and making things work in the real world. And I said on this one, I've covered it. Like, you know, most of us, we find ourselves in software. Most of us have got one thing in common. We liked either dismantling things when we were kids, and we've gotten some hiding because of that. The curiosity to always want to know why something works, and also this becomes your fuel. And this is something that when I am at work on my daily basis as a software developer, I do not get to understand why, because obviously there's business requirements, client already knows why. I don't need to understand why as a developer. I just have to, because the whole SDLC process, you will find ourselves having business analysts. We have a lot of stakeholders, business stakeholders, until it gets to the last person in the line, which is the developer and maybe QA after the development. So, which means this curiosity might only apply to maybe how solutions scale, but that's not fun, because once you actually know how to architect systems that scale, systems that work in whatever way that works for that business or that solution you're working on, then you're locked into that circle. You know, it kind of like feels like corporate. You know, I didn't want to say this, but in the corporate world, you get to use what's there. You're told what to use, and you just end up getting stuck in the loop. And with me, I get bored easily. Though I love my job, I love writing code, I love solving problems for businesses or clients. There's still that part of me that just wants to experiment and play around with things. So, like I said before, I started off as a mechanical draftsman. I did 2 years of college. I did my internship. But then at some point I had to drop out, unfortunately. But in this career taught me precision and planning. And this is very helpful in software. This is a very important soft skill that is applicable in mechanical engineering, and I believe in other aspects of engineering as well. And this has helped me in designing or being someone who wants to apply some of these things that I've learned. At the back of my mind, it's always there. How can I apply this knowledge? How can I apply this knowledge? And I find myself taking small ideas and building them into like bigger things. Then, the first time I wrote code and I could create something from nothing, I couldn't stop. And discovering IT is the best thing that has ever happened. And when I discovered this whole software world, I then discovered this software needs hardware for it to run on. So this is where my curiosity starts knocking. And, by that time, my spouse had some plants in the house, and some of those plants will die when I'm left alone with the plants. And I saw something online. It was an Arduino. And the Arduino, it was a whole set. There is a tutorial. You follow that tutorial, connect the whole thing. It was nice. The feeling was nice. I'd accomplished something on a Saturday afternoon, just chilling, having some drinks. And voila, this thing works. But this thing is offline. I can't control it. I have to connect more electronic communication boards to it for me to communicate with it. Like I need to add something that has to do with Bluetooth. I need something that is maybe that is Wi-Fi capability, then I don't just stop there, because now I have another problem. I've solved a problem, but a new problem has been introduced. It's still a Sunday afternoon. I am happy, but now I am not as happy because I can't control this smart watering system remotely. I need my spouse to be able to access the watering system, be able to see plant 1, plant 2, plant 3, see the humidity. But with the Arduino Uno, you can't. It only has USB serial connection, and that needs wiring. I can maybe create a server on my local computer, connect the Arduino Uno directly to my computer, save it via web, via an API, build a web application or a mobile application. That sounds so cool as well. But I still want to investigate how our devices actually communicate. So using serial or the bus connector, there's USB. If it's disconnected, which means we can't access the watering system, then I find myself learning more about electronics. That's where I then realized I was a Python and a React developer. And I realized the importance of C++, where it was actually applicable, because previously, as I was doing some boot camps, we're taken through C++, but people weren't really building with it. I wasn't seeing anyone using it for anything. And to me, it was like, okay, let me learn C++. Then I realized, okay, there's Arduino Uno in C++. Dived into that for a few weeks, and from that few weeks, my target was actually just altering the scripts that I had gotten from the package, making sure I understand, I can change things, I can log more values, and still at the back of my mind, I'm like, how can this communicate? Then I learned more about other microcontrollers, which are better than the microcontroller which powers up the Uno. We had the ESP32s. We had I think it's called the SMTP board or something like that. And the best board that I saw was the ESP32. It came in all sizes, into a size that is like, there is one that is peanut size, I think a pecan size, which is very compact and very good. It has Bluetooth, it has Wi-Fi on board. It doesn't need extra things on board. You just need to write the proper code for it to drive those components on board. And now I am able to even use the same script I used on my Arduino Uno would work on all these microcontrollers I was looking up. So there was no need for me to rewrite the code that I already had. And with that being said, I then realized that after using ESP32s, just like my Arduino Uno, I had a lot of wiring. So there are tools out there to do computer-aided drawings for electronics, schematics, which, for example, EasyEDA is a free one. That was my tool of choice, because even for manufacturing the PCBs, the company that owns EasyEDA are the manufacturers in China. Creating a PCB was like $5, which was quite affordable. So now you can make your schematic, send it off to China, it comes back. I had to learn how to solder a bit, because when the components come, they're not joined together, they're in pieces. I had to solder up a bit and test. But on my first test, it didn't work. Just like our code, it doesn't run on the first time. But it still kept me going, because this was me learning. And Sunday, you have to close the laptop, because Monday, maybe you've got pending tickets and stuff. So yeah, but next weekend we continue. But now, as we continue with the agricultural project, everything is working fine. I integrated it with the Gemini API. It was free for developers, different from the open API for your LLM, which means as I was getting data from my watering system, the AI actually knows what's happening at the watering system, so you can talk. It was more like you can talk to your garden now. And this board is still yet to be sent for production. I'm still scared to send it off again because I had to pay some customs fees on that. But then in the next weekend, there was a problem that we had at home. We had a break-in. And then my solution, I had a problem again. And with this problem, I knew electronics at this point because of what I had been researching, what I had been looking up, the videos I had been watching. One thing I want to point out, YouTube is a university of its own. All the information I've used to build this project, I've gotten it for free on YouTube. Just have to be able to look for the right stuff. YouTube, like, there's everything. You don't have to reinvent the wheel. You don't have to go like searching it on YouTube. You can just find the best tutorial. Then maybe you iterate from that solution that's there because it might be a basic solution. Then just like how we do in programming, same with the electronics things. So back to the home alarm project, I then think of a solution that is transparent, low power, and can work off-grid. So I thought about infrared. Infrared wouldn't really work because the infrared components I had would only work for a distance of 5 to 10 centimeters. That wouldn't be ideal for home security, especially in a house that's in a 300 by 300 square meter piece of land. So you would have a lot of those, which is not ideal. And then I thought of microwave sensors. There's this microwave sensor that bought like 20 of them. One was going for 15 rands. And yeah, with this microwave sensor, microwaves can pass through anything. They can pass through walls, they can pass through wood, they can pass through plastic, they can't pass through metals only. So the plan was shielding the whole house, around the house, with microwaves. The moment something gets into the line of the waves, they are sent back, and the home alarm system is alerted. But then when that happens, if we have animals, then the system will always be triggered. I have a new problem now, but it's the same weekend, so we can still solve it. You can still iterate on it. We don't stop. So now I had to research on how alarm systems actually work. Then I realized alarm systems, all the alarm systems that you find in shops and whatnot, they've got a way of verifying if it's a false alarm or a true alarm. So how they do that, they put two different types of sensors that do different things. And if both sensors are triggered, which means it's true. If one of the alarms is triggered and the other one is false, then which means it's false, then the alarm doesn't trigger. So in that one, I had to use a PIR sensor, which detects thermal heat. So basically now we're detecting if microwaves are being distracted or if there's also heat, and because our bodies radiate heat, so probably we have an intruder, then we ring an alarm. And this project worked. It was all ESP powered. I built a web server for it where the electronics board send the data to the web server. You can control the home alarm system through a mobile app. If a window A, so I even managed to tag windows and doors. So if window A is an intruder, you actually know where the intruder is coming from, those kind of things. And now I have these two separate projects full of wires, and yeah, I just don't like how it looks at that time. And then I thought about creating one board that can serve two purposes. And this board, I designed it in, I'm not sure if it's properly visible, but maybe later if we connect on LinkedIn, I've posted videos on the PCB design. So this is the PCB design I created. And with this one now, as it was merging the two worlds of home security and being a farm assistant, it is powered by ESP32. It has a LoRa board, which is called low range frequency. It's a scientific frequency that is used to transmit data from ranges of 5 kilometers to 10 kilometers, which would be very ideal for the farming environment where we have bad internet connections. So those things can communicate to each other until they get to the one which is at the house, which I usually call the master, and which means the whole system can be off-grid, or the one which is the master can have a SIM card and it transmits to a web server, which means you can talk. Basically, at this point, you can talk to the soil, because I added, during my research, I learned about electronics in the industrial space, on how industries in the manufacturing processes, how they monitor, they do their preventative maintenances. And I realized, just like in our web space or our mobile space, we've got protocols like TCP, UDP, and one of these protocols that was of interest is called the RS485. It's a standard protocol for communication within manufacturing industries, for electronics to communicate with each other. So most of the components you find out there would have an RS485 connector. That means if you buy it, you might buy it in China, it will work by the standards in Europe, just like USB-C or the USB-C implementation that you just see being shipped out currently. So in the electronics world, they've already had this going on. I think with OSI, there's something with the SI units or standards, I think. So, and with this board, it has ESP32 Wi-Fi on board. It can connect to RS485. I still need to iterate on it, because I put one RS485 connector here, but I believe I can have 2 or 3 more, so that this can actually be applied in more spaces. So this board, the goal, in as much as I proved it can work for these 2 worlds, I believe it can be applied. Sorry for that. I believe it can be applied in the real world, in industry, using these protocols, or just following these already existing protocols and just integrating. The special thing about this whole thing is always our software, the brains. Once you learn your Python, you master your Python, or once you learn your C++, this will be able to run in the C++ that you currently have. Your current program that you have is, you can see all these components are for connecting our sensors, our external sensors. And yeah, so same hardware, different firmware. So it will just depend with the industry. So the goal with this, besides the homes and the farms, will be just maybe trying to expand on it and see more applications of the components. But in this whole thing, what I've realized in electronics and also in programming, communication is key. So when I say communication is key, more our communication protocols. So you have to understand communication protocols, why we use this one over this one. For example, I'll give you a basic example, if you've ever thought about it, why your phone, if your phone is low on battery, if you switch it off and you turn it on again, the battery will be lower. You would have lost some power. And the solution to that is rather put it on airplane mode and keep it on. It will save the power, because the GPRS protocol eats a lot of power and it uses up a lot of energy, even in our cells, in our communication, our cell towers. They use up a lot of power and energy to transmit our 4G or 5G. So we can have things like the low range communications instead of using a SIM card in your electronic setup. So if you use your basic LoRa would use at least maybe around, it doesn't consume that much voltage. So you might find with one LiPo battery, it will last you like a year. this system can be installed in a farm on one battery and it will last you for like a year, but doing all those communications, and maybe with your code, you send heartbeats to your server and be able to trace how much power or voltage is left in your system. So the lessons I learned in this whole journey is that curiosity drives progress. In as much as these things seem like they're just electronics or AI, there's a lot that I've learned that also contributes to my software development career or journey. I've had to deploy my own server locally at home so that I can host my machine learning models. I can host my LLMs. I can have my Olama running from home. It has helped me be able to understand virtual private networks, how virtual private networks work, how you use tunnels to then expose a certain service to the internet, how firewall configurations work. These are things that we learn when we do certifications, but we don't always have the funds to have your AWS server running and being able to monitor the VPN there. You get this big bill, but playing around. So rather get an old computer, spin up Ubuntu or a Linux server, install your Pocket, install your Proxmox for virtual machines, spin up pods, spin up containers, set up your Kubernetes, be able to manage infrastructure even on your local, and it will help you build more because now you've built the infrastructure that you need and it's running local. Even if it's down, no one will really complain. It only serves you. And yeah, it just helps. And prototypes are always a step forward to problem solving. It might be whatever space you might be in, as long as you're in IT, one aspect of IT will always complement the other. So thank you for listening to me talk about my research and findings, and hope there's one or two things that I shared with you that you take out there and start applying, and always try to have a hobby. Some people think I'm weird when I'm doing, because they think it's still my job. But to me, I always tell them it's not my job. This is actually my hobby, because actually software development was actually a hobby I discovered that people could pay me for, I could live off of. So, which was quite of like a bonus. So I can't really stop because I do it daily. So I will always continue because it's something fun to do. So if you do these fun things, you obviously won't get bored with it. And yeah, I can't wait to see amazing things from the community. Thank you.
Cool. Thank you so much, Elisha. That was a brilliant presentation and nice, innovative things. I see nice comments coming all the way. One from Sylvester, he says, I just realized I've been missing a lot. I'm a special scientist and I'm so into precision farming. Thumbs up for the watering system. Nice and informative session. Thank you. I do not see any questions. Would there be any questions? Are there any questions? If they are there, please quickly type them on. But while we're waiting for those ones, Elisha, my question to you is that, well, I've got two questions. The first one, all in all, how much time did it take you from the time that you started developing it all the way to the time that you managed to implement this solution? Then the second one is that, is this, what's your plan? Are you keeping this solution that you have done to yourself, or you intend to eventually make it a business, share it somewhere else? What's your plan on it?
All right. Okay, thank you for the questions. So first question is the time. So I would say I started working on this project in 2023. So I wouldn't really lie to the community to say you can do it over 2 months or 3 months. It took me a while to actually get to where I am or be able to maybe do or design what I do or the things that I build. Because also I do it mostly in my free time, weekends, at night, you know, things like that. In terms of the question on what I intend to do with it, so we applied for TIA grassroots funding last year, got approved, but mostly there's delays in actually getting the funding to actually maybe start getting off the ground. So that was grassroots funding to actually try to help us get off ground, but in the farming sector, because what I had presented to them was more the AI farm assistant powering IoT systems, and I built a vertical garden that was a hydroponics garden that splashes water up and waters the plants. So it was more you talking to the water, knowing the nitrogen, the potassium through an industrial soil sensor that I had gotten that got me to learn about the RS485 communication protocol. So that's the path we're trying to take, because it was more of if we get like more assistance in terms of funding or looking at the SDG goals. Well, if we get some funding on maybe trying to food security, things like that, it would ship more, because the target was more low-scale farmers and middle-income farmers who actually have some of their stuff for commercial. They always put it up for commercial. They would need access to this kind of systems, but the challenge would be getting funding to train, to inform. You know, farmers are kind of out there, so it's kind of hard. You might need some initial funds to actually try to get to them, get to inform them, get to experiment or try out the solution. So that's where we are. Where at this moment now, I'm just innovating more on this thing that I had built, where the goal was actually to target in the agriculture, because we're looking at the SDG goals, the impact it can have. Because with home alarm systems, it was more of a premium kind of service, where not everybody might afford it or will afford it. The goal was making it cheap all the time. It's like making affordable electronics components for the African community or for the SADC community in general. So yeah, that's like the direction that I would like to take on this, or that I'm taking this, if I'm to say.
All right. So we've got a question from Clinton. He says, how do we get the system?
So the system at the moment, if it's the home alarm system, the only way is getting it through me, where I have to maybe build it customly for you. And if it's the agricultural system, it will be the case as well. Let's say if you have a plot, we try to plan out how your plot looks like, how many sensors you need, and we plan the whole setup. That's the kind of way you might get it, because it's not really like out there.
All right. We've got a question from Anna. Anna says, have you searched for international investors?
No, not yet. You know, as a developer, the challenge mostly we always face is working alone. More of a techie, you know, tech head, over engineering all the time, and lacking on the marketing side of things, trying to talk to people. That's usually a challenge. But obviously, when you get to collaborate or meet with people that can do that, or that have those networks, or are part of those networks, I'm willing to connect or collaborate, you know, and see if we can take it somewhere.
All right. From Philip, I see the question says, will I have to download the app online for the home system, or you provide an APK?
Yeah, you have to download it. We're using a native app called Blink. You should look it up if you are into electronics. So I used Blink. It's an already made app out of, it's already shipped. It's a, what do they call them? White labeling app. They've got a white label thing. So you download it from the store, but because you're already subscribed and your email is within our database, once you log in, you already see your house if the system is installed.
All right. Thank you for that. Let me see if we have got any questions. Are there any last-minute questions before we call it a day? Okay. Anna says there's a business consultant who can help with putting your proposal together. How do I send his details? So if you want, Anna, if you want, you can send me an email, and then if Elisha agrees, well, I'll just forward your details to Elisha, and then the two of you can connect. Will that be fine?
Yeah, that works.
All right, great. So I'll do that for Anna. Who keeps the data for the home alarm systems? From Philip. I think the question is, do you keep the data, or does the person that use the system actually keeps their own data? Where is the data stored? And then just to expand it, if someone no longer wants to use the system, will they be able to get their data, or their data will be erased?
So currently, how the system is set up, all the data is in a server, it's decentralized. But decentralizing is possible. For example, like in my solution, the place has no security companies that will respond quickly. So it was more reliant on the CPF, right? So then we have this, you just have this big siren. So you might just want it offline, off grid, but you can access it from your phone if you have your private Wi-Fi. So, which means your data will be kept in your home or in your house or in whatever way that we can. But obviously, you need one more component that's more of a microcomputer than a microcontroller.
All right, all right. I hear you. Is there any other questions? Let's just. So if any other question comes up, let me just paste our email address on the chat. But what I feel like doing, Elisha, because of the interest that's there, I think it feels like we just need to organize a tour and come and see exactly what you're talking about working. I'm sure quite a number of our colleagues will also be interested in doing that. So whenever you're available and ready, I'm sure I would gladly take the offer to see the practicality of your solution.
Yeah. No, that will be quite interesting because I recently also got a 3D printer. So my stuff is going to be looking professional very soon.
All right, awesome. Thank you so much, Elisha. Thank you so much, colleagues. There are no more questions. Our next event, we are trying to aim for it on the second week of September. But on the 9th of September, we have got the LeaderX event. So we are encouraging all of you to attend. That's it from my end. I'll hand over to Kelvin to do the closing remarks, and then we end the webinar. Thank you so much for attending. Over to you, Kelvin.
All right. So thank you, everyone that in the room from IITPSA. Thank you very much. And like Kurai just mentioned, we have a big event, a big in-person event happening on the 9th of September called LeaderX. Look out in your emails. You'll get information on how to register. We have secured access for members of IITPSA to this event. It's going to be huge. The IITPSA have the whole day presenting different topics and thought leadership. The different SIGs are taking part. The Gauteng chapter, because this event is in Johannesburg, is taking part. So thank you very much for attending. Have a good evening. Thank you.
Thank you all. Goodbye.